relationship between moles, number of particles, and the Avogadro constant is as follows. So we're going to use the following letters. Capital N, number of particles. Lowercase n, number of moles. As we said already, the n with the subscript A represents the Avogadro constant. That's 6.02 times 10 to the power of 23. Okay? And there is the formula that we use. Okay? And this is only to find the number of particles. Okay? Which means if we wanted to find the number of moles, we'd have to isolate for number of moles by moving this over to that side of the equal sign. Alright? And obviously, we don't really need to find that because the Avogadro constant is 6.02 times 10 to the power of 23. So we know that the variation, so if we needed to find number of moles, we isolate for n, okay, and we get the number of particles divided by the Avogadro constant, if we were trying to find the number of moles of something.
Also, just need this equation.
You use this equation, right? So we can simplify what I've already showed you, okay? Or you can use my rule for what they call factor labeling, okay?
So we have to memorize this equation.
Well, see, you can either memorize this equation or know about the rule for canceling, right? Remember how we canceled mole and mole, right? So if you know how to do that, you won't really need to worry about the formula, okay? How many atoms are found in 0.25 mole of potassium? Okay, so really simple, similar to what we're looking at, but we're looking at potassium, so we're looking at just the atom itself, right? So, in reality now, we don't have a full mole, we have less than that. Okay. So, we start off, we want to find out the number of atoms, so the number of moles, Avogadro number. Now, here it is, the way I wanted to show it to you guys at the beginning. So we have 0.25 mole, okay, of potassium. But now, we know that in 1 mole is equivalent to 6.02 times 10 to the power of 23 atoms. Or 6.02 times 10 to the power of 23 atoms is equivalent to 1 mole. They're both the same. But we are going to multiply this by one of these, either this or that, based on which one will allow me to cancel out mole. Which one will allow me to cancel out mole? First one or the second one? The second one. So, mole, what we were trying to do, let me show you in a different color. Mole, we're trying to cancel out. So all we're doing, just like the equation showed us, we take the number and we multiply it by 6.02 times 10 to the power of 23. Okay. And that's what we end up doing there. And there's my answer. Okay. So once you've multiplied all this together, that's what you get in terms of the number of atoms of potassium. Okay, 1.51 times 10 to the power of 23. But now, what are the least number of significant digits in my question? 2. So my answer must be simplified to just 2. 1.5 times 10 to the power of 23. And don't just leave the number, right? Remember, units, right? So the units are atoms of potassium. Okay, next one. How many atoms are in 1.25 mole of water? How many atoms are in 1.25 mole of water? So, we know we have 1.25 mole of water. Okay, so we're going to multiply it by, for me to cancel out moles, where must moles be? The bottom. The only thing is mole, okay, is this water here an atom? No, it's a molecule. So technically we're looking at 1 mole is equivalent to 6.02 times 10 to the power of 23, not atoms, but molecules. Okay, so we're looking at molecules. So now we are going to get how many molecules are in 1.25 moles. Okay, so our answer when we've canceled out mole will give us molecules. But we're trying to find out atoms. Right? We're trying to find out atoms. How many atoms are there in 1 molecule of water? Which are they?
Hydrogen.
How many? 2 hydrogen, 1 oxygen. Okay, so there's a total of 3 atoms in total. So what we're going to do is, let's find this result first.
Divided by 3.
Okay? We'll watch what happens. So we're going to multiply those 2 and we're going to get the number of molecules, not the number of atoms. Before we did it, because we were talking about potassium, we were talking about, specifically aluminum. Okay, but now we're actually looking at an actual molecule. Okay, so when we multiply that, so we're looking at molecule because water is a molecule. Okay, it's not an atom. We have atoms within that make up this molecule. Okay, so when we calculate it, we get the following: 7.53 times 10 to the power of 23 molecules of water. So 0.53 times 10 power of 23 molecules, okay, of water. Now we're going to multiply it by something. But now I don't want my molecules units, right? This is where we're talking about the factor labeling, trying to cancel out. So we are always multiplying it, let's say, by a fraction. I want to do this. So what word should I put down here? Molecule, right? But now, in 1 molecule, let's get rid of that S. In 1 molecule, how many atoms are there? 3. So there are 3 atoms in 1 molecule because we're referring to here water.
So it was bigger than say from H3O, and there'd be 4.
It'd be 4 atoms, exactly. You could have a formula that could be something like, let's say, phosphoric acid.
That's like,
And then you're going to have to break, you're going to have to kind of do the same thing, but it won't be 3 atoms in 1 molecule. It'll be, 8 molecules in atoms in 1 molecule.
that's right.
So what we're going to do is then we're going to take these out, and now my molecules here cancel out. What am I left with? What units? Atoms. So I know that if I have this many, if I have this many molecules, but that 1 molecule is made up of 3 atoms, I'm going to have 3 times the amount of atoms as that, because in 1 molecule I have 3 of them. So we're going to multiply this by 3, and we get 2.26 times 10 to the power of 24 atoms in 1.25 moles of water.
That's good.
Okay? And again, same thing. We have how many significant digits in my question? The least number? 3. And my answer also shows 3 significant